Hello all. Welcome to the webinar on Smart Tips on Application Load Balancer. I am Narayan Subramaniam, and with me we have Priyank Goyal and Varun Lodaya, and we are all from the Elastic Load Balancing team in AWS. So let's get started. To start, we're going to give you an introduction for what is the Elastic Load Balancing family. Currently, we have three types of load balancers in the load balancing family. Application load balancer is best suited for load balancing of HTTP and HTTPS traffic. The application load balancer, or ALB, operates at the request level and provides advanced request routing features such as path and host-based routing, WebSockets, HTTP2, and other visibility features targeted at application architectures, including microservices. Next in the list, we have the network load balancer that is best suited for load balancing of TCP traffic, the transmission control protocol traffic, and transport layer security, which is the TLS traffic, where extreme performance is required. The NLB operates at the connection level and are capable of handling millions of requests per second while maintaining ultra-low latencies. In addition, the network load balancer also supports what we call the static IP functionality, where you get a single IP per availability zone. Finally, we have our older generation classic load balancer that provides load balancing across multiple EC2 instances and operates at both the request level and the connection level. However, a point of note here is that we are not actively adding any more features on the classic load balancer. All our investments are now on the newer platforms of the application load balancer and the network load balancer. So use the classic load balancer only for applications that were built using the older EC2 classic network, and if you're not using the VPC. So now let's look at some of the advantages of what the Elastic Load Balancing family offers for you. The first piece is the elasticity. So Elastic Load Balancers offers elasticity where we can scale automatically based on the incoming load. The next piece is the security aspect of it. We support end-to-end traffic encryption using the latest protocols and ciphers, and we handle the whole TLS management for you so you can focus on building awesome applications, including the certificate management aspect that is also handled by us. In addition, we also have what we call as the predefined security policies, where we have automatically picked the right ciphers and protocols for you, and you can simply select these default policies. The other one is integration with the broader AWS ecosystem. Elastic Load Balancer are integrated with up to 14 other AWS services, including auto-scaling for scaling requirements for your backend targets, Route 53 for DNS, Amazon CloudWatch for metrics, ECS and EKS for containers, Code Deploy for deployment, AWS config, ACM, which is the certificate manager, and WAF. And so this integration is seamless, and we are integrated with these various other AWS services that are available. Finally is the cost effectiveness. Elastic load balancing is extremely cost effective. It is less expensive to run an ELB than to try and do it yourself with EC2 instances. With ELB, you pay for what you use. Before we get into the deep dive for the specific areas that this webinar is for today, we wanted to quickly go over some of the recent features that were launched on the application and network load balancer. So let's start off with some of the supports that we had for filtering by tags on the console. In addition, also we added support for resource and tag-based permissions on both the ALBs and the NLBs. This enables customers to implement fine-grained access controls on their load balancers using IAM policies. Application load balancers also now support a slow start mode that allows you to add new targets without overwhelming them with a flood of requests. With the slow start mode, targets warm up before accepting their fair share of requests based on a ramp-up period that you can specify. We added support for authentication that allows you to configure an application load balancer to securely authenticate users as they access your applications. This enables you to offload the work of authenticating users to your load balancers so that your applications can focus on their business logic. We also added the ability to have Lambda as a target on ALB. So you can now have Lambda functions in addition to EC2 instances and IP-based targets to the load balancer. We recently launched advanced request routing beyond the path and the host-based routing that we already supported. Uh, Priyank and Varun will be going deeper into each of these three areas: user authentication, AWS Lambda as a target, and the advanced request routing during rest of the presentation. So very quickly, let me also cover some of the other recent features that we launched on the application load balancer and network load balancer. We also added more TLS policies to our load balancers. These were the predefined policies that I was referring to earlier when I talked about security. These recent policies implement ciphers that ensure forward secrecy. On the application load balancer, we also added ability to do redirects natively from the load balancer, where you can redirect from AT to 443 or HTTP to HTTPS, or from one URL to another. Fixed response is another interesting feature that we added to the ALBs that allows you to send a fixed response from the load balancer itself based on certain conditions. Now coming down to the network load balancer, we added support for cross-zone load balancing, added support for inter and intra-region peering and VPN. In addition, most recently, we added support for TLS termination on the load balancer that allows you to terminate TLS on the load balancer itself while still preserving the source IP of the clients. This was more of a broad overview of some of the most recent features we've launched. So at this point, I'm going to hand over to Priyank to dive deep into each of the features, which was the focus of this webinar, and also Varun, who will be actually walking us through each of the features, including the demos.
Hi everyone, welcome to the webinar and thanks for attending the webinar today. My name is Priyank Goel and I am product manager in Elastic Load Balancing team. So let's dive deeper into each of these features. The first one we will cover today is advanced request routing. Then we will cover Lambda functions as targets. And then finally we'll also deep dive into authentication. So let's dive into advanced request routing first. So this was the feature that we launched very recently at the Santa Clara Summit in March. Now, what is advanced request routing? Basically, as part of this launch, we bundled 4 new request routing criteria uh, into the content-based routing module of ALB. And these new criteria are standard or custom HTTP headers, standard or custom HTTP methods, query parameters or query string based routing, and then source IP addresses based routing. Prior to this, we had support for host header and path based routing. So essentially, what we did with this launch is that now we are offering you ability to route based on pretty much any field in an HTTP request except the body. Let's look at a typical request. What you see in front of you is a GET request. Now you will see that the first line, which is request line, here pretty much everything is covered as a first class routing key support. Start with GET, which is basically a method. So you can route based on method. Then you have path, you can route based on this. Then you have query string or query parameters. You can route based on them as well. The next thing is a host header. As I said, we have a first class support for host header based routing that existed from the launch. Now, what we have also added is ability to route based on any custom or standard header, right? So that's what you see at the last thing there. So essentially, you will see that pretty much everything is covered in an HTTP request. So let's look at the use cases where you can benefit from these new routing criteria. Now there are a variety of use cases where customers have been using them. Let's look at some of the dominant use cases here. So starting with, you can use user agent based routing for, let's say, separating bot traffic from human users and provide a different kind of experience to each of these categories. Similarly, you can provide a variety of user experiences based on the category of devices, again using the user agent header, or the geographic location of users using the source IP addresses based routing. The most dominant use case that we have seen for query string based routing is A/B testing that we are all familiar with. Similarly, on the deployment side, I have heard customers telling us that they want to use header based routing for blue-green deployments or canary deployments. On the microservices front, uh, the method-based routing comes very handy when you want to have microservices handlers based on methods. For example, you can have get and head methods routed to a read service while you route post and put methods to a write service. And finally, you could also employ access restrictions based on IP addresses or CDN networks using, again, header-based routing and IP address-based routing. Now, let us understand how the actions and conditions work in ALB rules. A rule can have one or more conditions and one or more actions. Now, we already discussed the types of conditions supported, and Narayan did cover the actions that we launched in addition to the forward action, which is an obvious one, the redirect and fixed response. The last one is authenticate that we are anyway going to cover in greater detail today as well. So basically you have these routing criteria, which are basically the conditions, condition types, and then you have these actions, 4 actions available to you. Now let's take an example of header based routing. So you will provide a header name that we will match exactly, and then you will provide one or more values that you want us to match. The way it works is that within a condition, you can provide multiple values and we will do logical or evaluation among them to finally match that condition with your request. And if you want to have a logical AND operation across different values, then you can provide those values across different conditions. It could be the same condition type or it could be different conditions type. So this is how fundamentally rules work. Now, there are some more sophistication that we have provided with this latest launch. We basically allow you now up to 5 match evaluations per rule, right? Now you can consume these evaluations in one condition or across up to 5 conditions. It doesn't matter. The limit applies to the rule level. Similarly, you can also use up to 5 wildcards per rule. The overall limit of 100 rules per load balancer still remains the same, but now by virtue of this flexibility of 5 values in one rule, you can actually combine multiple individual rules to fewer rules. Or, let's say, for example, path-based rules where let's say you were saying the slash login and slash sign in were forwarded to the same target group. Now you can do them with one rule rather than 2 rules. So actual example of header based routing. So what you see in front of you is, you being trying to do user agent based routing. So you will provide the header name, which in this case is user agent. And then let's say you wanted to do something, a special user experience for Chrome and Safari browsers. So you give them as a values. And you could further qualify this condition, let's say using path condition. Right? So this is an example of how to do header based routing. So we will actually cover this in actual demo where you will get to see how to set it up and actually seeing the advanced request routing in action when Varun does the demo later in this session. Now let's dive into Lambda functions as targets. This was launched in reInvent last year. Before we dive deeper into Lambda functions as targets, let us first understand how we have approached the ability of allowing customers to bring different kind of compute abstractions behind application load balancer. So when we launched application load balancer, we launched with EC2 instances and containers as targets. Then we expanded this with support for IP addresses as targets that basically allowed customers to bring on-prem servers as targets to the load balancer and also do hybrid load balancing when some of the targets are in AWS while the rest are in on-premises and they could migrate over time gradually. The idea behind this was that we can provide customer a single HTTP endpoint for all these different compute abstractions. Very recently, we launched Lambda functions as a targets to enable even serverless compute behind ALB. So overall, what we have done now is that you have ALB as single HTTP endpoint for requests served from anywhere, could be from EC2, containers, on-prem servers, or Lambda functions. So what are the benefits of Lambda functions as targets? Let's look each of them. To start with, you can build websites as serverless code. That's the obvious one that you want to do. You have AWS Lambda as a managed service to manage and run your functions. ALB as a simple HTTP front end for all your workloads, whether they are EC2 or containers or Lambda. You can do both HTTP and HTTPS protocol based front end connection with ALB. This is an important one. Essentially, if you have legacy clients like legacy televisions which want to invoke your Lambda functions, then you also have an option of HTTP that today, for example, API Gateway does not provide. There is no restriction on programming languages. All programming languages supported by AWS Lambda can be used with ALB integration. You get the power of content-based routing in ALB, where you can build sophisticated applications just using Lambda functions by forwarding your request traffic to multiple Lambda functions. Not only that, you can build hybrid applications behind ALB and use mixed compute for your applications like EC2 and Lambda functions or containers and Lambda functions. And finally, you can also extend the type of target behind ALB than what is natively supported. For example, you could serve a static website to your clients with Lambda function fetching that website from S3. Now let's look at how to set up Lambda functions as targets in ELB. So first thing you will do is you will author your Lambda function. Then you'll create a target group with target type Lambda. The next step is important one to note. Now you will need to provide permission to ELB to invoke your function. And we recommend that you provide this permission at the granularity of the target group that you just created. Otherwise, if you provide the permission at just the ELB service principal level, then essentially any load balancer in your account can invoke your Lambda function. Then you will register this Lambda function ARN of that function ARN to the target group you just created. And finally, you'll associate this target group with a listener rule and you are ready to go. Now your clients can basically invoke the Lambda function. One thing you should note is that today we don't support cross-account Lambda invocation. So ALB and Lambda functions should belong to the same account. There is also an easier way for very simple applications where you are a Lambda, you are conversant with Lambda Console, where you can, with very few steps, create ALB as a trigger in Lambda Console. So as you can see from the screenshot, when you go to the dashboard for your function, in this case it's hello world, you can choose ALB as a trigger, right? When you choose this trigger, you will have application load balancer as a trigger, and then it will require some configuration. And it's a very simple configuration that you need here. So you will basically be asked for a load balancer that you need to choose. You will be shown a drop-down list of all the ALBs in your account. Choose one of them. Then you choose a listener. Typically, you will have an HTTP or HTTPS listener. So choose one of them at a time. If you want both, then you need to repeat this process twice. And then you can provide a host and path input, which will allow us to put this into content-based routing engine to decide when to call your Lambda. Now, you will need to provide at least one of them. So you can either provide host or path or both. With this, you are ready to go. Right? Once you do this, you can basically again have your browsers call your Lambda function. There is one cool thing that we have added with the Lambda integration with ALB, and this is health check support in for Lambda functions. This is how it works. It's an optional capability because you will incur cost of health checking for Lambda invocations. So the way it works is that if you cannot tolerate any downtime for your application, in case let's say your Lambda functions have some problem or the downstream dependency that Lambda function fetches information from is not working. The way it works is that you will create two application stacks, let's say in US West and US East, right? Equivalent stacks in both the regions. Then you will configure a domain name for your application with DNS failover policy. So essentially, you will create an alias record set in Route 53 and set DNS failover for it. So the primary FQD, primary load balancer in this case, let's say is US East one. So that will be your FQDN of that will be set as a primary, and then FQDN of the load balancer in US West will be secondary. Now, by virtue of this DNS failover, uh, Route 53 will be able to switch over to the load balancer in another region when one region fails. Now, this is how it works. So let's see. Let's say there is a failure either at the Lambda function level or at the downstream dependency level. This health check failure will be propagated to the Route 53 as well. By virtue of this notification, Route 53 will start directing your users to now the ALB in a different region. So basically, this will give you a highly available application across two different regions. Now, there are two important things that you should also know about, right? That what is the structure of the event that ALB invokes have? What is the content that you get to your Lambda function when ALB invokes them? So what you see in front of is a JSON structure. The important things to note here is that you get a target group ARN that you can use for context. Then you will get all the information of the original request from the client, like HTTP method that was used, the path, query string parameters, all the headers and the body. You will see there is a flag called each base 64 encoded with value being could be false or true. This flag indicates whether ALB converted the binary body received from the client to the base 64 encoding before sending it to your Lambda function. We have some typical content types for which we send the body as it is, but for other content types, it is sent as base 64 encoded, and accordingly the flag is set to true or false. Similarly, this is the structure in JSON again of what is expected as a response from Lambda function. The fields you see here are not all mandatory. The only mandatory field is status code. But you could basically form the whole response as you desire with the kind of information you want to put into the response header that needs to be sent to the client back. So here again, if you need to send binary body to ALB, you will base 64 encode it and then JSON serialize it and then send it and accordingly mark the flag so ALB knows what type of content it is. Let's look at the limits, because this is also an important point that customers are often confused about. So the first limit is what is the size of request body that a client can send and then can be forwarded to the Lambda function. So the limit is 1 megabyte. And please note that this limit is only for the body, right? We have a limit of 64 kilobytes for the headers, which generally applies to any target type. Similarly, for the response that the Lambda function can send to ALB, the limit for that is 1 megabyte. So this is for the whole JSON response that you form or manufacture. That is what is limited to 1 megabyte. On the pricing front, there is no change to the hourly price of ALB. The only addition is that now on the process bytes dimension of LCU-based pricing in ALB, you will be charged at the rate of 0.4 gigabytes per hour for Lambda traffic, or the traffic that is targeted towards Lambda functions. And in addition, you will incur usual AWS Lambda charges for invocations to your Lambda function by ALB. So this was a short overview of how Lambda functions target works. Now let's dive into the final topic of today's session, that is authentication. We launched authentication about a year back, and we have seen time and again that customers need education on how to configure it. So we'll focus on that part in this session today. So what is authentication in ALB? It is basically a facility to authenticate your users for your application, uh, so that you don't need to take care of that in your application and just focus on the business logic, right? So that part can be offloaded to ALB. Now there are two ways you can do it. One is through the native integration with any OpenID Connect compliant identity provider, which allows you to bring your own identity provider, right? So for example, if you're using Okta on premises, you could have ALB integrate and do the authentication handshake with Okta. The other option is the integration with Amazon Cognito. Here, basically, you can use it for authenticating with, let's say, corporate identities using LDAP protocol or OIDC protocol again. You could also authenticate your users with social identity providers like Facebook, Google, and Amazon. Now let's look at the authentication flow for the option where you are asking ALB to handshake with your OIDC compliant IDP directly. So the way it works here is that you will have a rule. Let's say you have your site mysite.com, and you want there's a video application which runs on it, and you just want to access it with authentication. So you will put that in the rule with authentication action. Now let's see what happens step by step. So user sends HTTP request to watch this video. Because this is the first request, it does not have a session cookie that ALB looks for to allow it to go through. So ALB will redirect this request of the user to the IDP. User will basically enter username and password typically at the IDP portal, right? And at that point, an authorization code is issued to ALB. So the user is redirected back to ALB with that authorization code. ALB authenticates the code and sends it to the token endpoint afterwards and receives JWT token in exchange from the token endpoint. Then ALB sends access token, which is part of the JWT token, to the user info endpoint to get the user claims. After receiving user claims, ALB redirects the user with a session cookie to the original URI that he wanted to access. When a user comes back to the origin URI with the cookie this time, ALB will validate this cookie and then forward the request to the target or the application, including the uh, info related to the user that was received from the IDP in the form of some HTTP headers that we'll see in the next slide. And finally, the application will send response back to the ALB, and then response will be further forwarded to the client. As I said, this is important to explain how to configure each of these integrations. So let's look at the native OIDC configuration first. Here you will basically configure the IDP endpoint, which is a URL by itself, and then all the endpoints that we talked about, right? The token endpoint, authorization endpoint, and user info endpoint. The next two parameters are client ID and client secret. These are basically parameters that helps IDP to authenticate ALB as a trusted entity to do this handshake with the IDP. Then you have session cookie name. We have a default cookie name that could work, but if you're using multiple IDPs, then you need to configure one for each. There is a default session timeout for the cookie of 7 days, but the range is 1 second to 7 days that you could configure again. Then the scope is basically the parameter that tells the IDP what's the level of detail IDP needs to provide during this handshake. And then you have different options in addition to authenticate for requests which are unauthenticated, what to do in that case. So you could have option of deny and allow to support typically JavaScript use cases or single page application with JavaScript. Now let's look at the Amazon Cognito based integration as well. Again, most of the parameters are same. The only thing which is different here is that instead of IDP endpoints, now you will basically configure the user pool ARN, which is basically a user pool ID that you have in the Cognito configuration, the client ID for the Cognito user pool, and then user pool domain. And then rest of the parameters are same that we discussed earlier in the native integration case. This slide shows you the information that is received by your application targets. The first one is access token, and the second one is identity in the form of subject field from the user info endpoint. Both of these are in plain text format. And the last one is the data. This is what contains the user claims in JWT format, which is basically base64 URL encoded and also includes signature to just verify that this indeed came from an ALB. So basically with this, I will hand it over to Varun, who will now take you through each of these features and show you how to set them up, and you can actually see them in action. So
Thanks, Narayan and Priyank. We'll be demoing 3 ALB features today. We'll start the demo with Lambda functions as target. We'll then use the recently launched advanced request routing feature to route to different Lambda functions. And finally, we'll secure our Lambda functions by putting ALB authentication in front of them. So without any further ado, let's dive straight into the demo. In the interest of time, I have a pre-created load balancer. As you can see, I have two listeners, HTTP and HTTPS. We're using the custom response feature on ALB as a default action to respond with a cat image. Let's test that out. As you can see, we are being rendered a cat image from the custom response. We're now going to add a new. We're not going to add a new rule. If the condition has path serverless, and if the query string has pet equal to dog, we are going to route to our demo dog Lambda function. We also add one more rule. Similarly, if the query string has serverless, the path has serverless and the query string has pet equal to cat, we're going to go to demo cat. So what we just did is we basically used the advanced request routing features to send the request to different Lambda functions based on the request parameters. We demoed query string and path, but as you can see, we have you can actually use client ID, you can use source IP, you can use any HTTP header, you can use the request method too. Now that we have the config pushed, let's test it out. So go to the same URL. If you remember, we had to put serverless. I'm going to do pet equal to dog. And we are served by the dog Lambda function. I'm going to change the pet to cat. And we are served by the cat Lambda function. Now that we have the Lambda function and the request routing demoed, we're going to move to securing our Lambda functions. I'm going to be adding auth action in front of the Lambda function. So let's go and mutate the demo cat and add a new actions called authenticate. As you can see, we have two different authenticate actions, Amazon Cognito and OIDC. In the first part, we're going to use the OIDC action. For the purpose of this demo, we are actually using Google as identity provider. Every identity provider has a discovery endpoint. You can refer to your own identity provider's discovery endpoint to get all the authorization, token, and user info endpoints. And you need to feed in all these endpoints directly into the console. Once you have all the endpoints fed in, you also need client ID and client secret. Every application, these are the credentials which ALB will use to talk to the identity provider. Every identity provider has different way to configure this client ID, client secret. Please refer to identity provider documentation. In Google, we created a Google app which gave us the client ID and client secret. Once you feed in the standard fields, there are some default options. You can actually leave the default options if you don't care about them. But please note that if you're going to use different identity providers on the same ALB, we recommend you to use different cookie names so that ALB doesn't mix up different sessions across identity providers. For the purpose of this demo, I'm going to name them OIDC cookie and Cognito cookie. Once we get to the Cognito demo, I'm going to leave every other option as is. Again, for the scopes, you can refer to your identity provider to get the right scopes. Once you've configured that, looks like we had a mistake. We're going to go back and update that again. Okay, it's a default copy paste mistake. All right, so once the rule is done, till the config gets propagated, I wanted to show one thing real quick. Please note that on your identity provider, inside your developer application, you have to go and whitelist the load balancer URL. This is so that once the user logs in, the identity provider can redirect the user back to ALB. The format is https:/DNS name /auth2/IDP response. If you are using a CNAME, replace the DNS name with the CNAME. Now we'll go hit the URL, the same URL. Let's go and check which rule we added auth action to. So we added the auth action to pet equal to cat. So we're going to change this. So once we hit that, you get redirected to the IDP's login page. I'm going to log in with my credentials. Once I log in, I'm into the cat application again. So now that we demoed the native OIDC, I'm going to take this, I'm going to actually go and demo the Cognito also. So what we're going to do is let's add a new action. We're going to say path is server. And then I'm going to add, we don't need a query string. Let's just go add an authenticate action to it. I'm going to say authenticate with Cognito. I have a pre-created user pool, which I'll show you in a moment. I'm going to pick that. I'm also going to pick a pre-created app client. I'm going to leave the advanced setting as is, but the cookie name. As I said, since we are putting two authentications on the same load balancer, it's recommended to use different cookie names. So I'm going to use Cognito cookie. And then everything else stays as is. We also have to have a forward action. So I'm going to forward to a demo TG. This is a EC2 target group with an EC2 instance backing it. I'll show you in a moment what that does. So till the config is getting propagated, couple of things real quick. So I'm going to show you the Cognito user pool we have. So few things I wanted to point out in the user pool. The first is federation. Cognito provides you a way to federate with different identity providers like Facebook, Google, Amazon, any SAML-based LDAP, or OpenID Connect based IDP. For the purpose of the demo, I've picked Facebook. You can also go and map the Facebook attributes to Cognito attributes. I've mapped a couple of standard fields like ID and email. You can map as many as you want. Second thing is domain name. Cognito lets you feed in your own domain name or use Cognito's root domain and just have your subdomain. I'm using Cognito's root domain and a subdomain. And the last but not the least, app client settings. Please note that this is the most important setting in Cognito for ALB Cognito to work. This is exactly same as the app I created in Google before. So what I'm doing here is I'm actually enabling different identity providers like Facebook and Cognito user pool. And I've also registered a callback URL. This is similar to what I had registered in Google, load balancers DNS name /auth2/IDP response. This is important because you want Cognito to be able to redirect user back to ALB once the user is logged in. Now let's go back and test the Cognito action in Cognito in action. So as you can see, if we hit the path server, we authenticate through Cognito. So I'm gonna change the path to server. Once I hit it, I get Cognito's standard page. Continue with Facebook or sign in with user pool. If you would have added multiple IDPs, you would have seen more IDPs here. Since I only added Facebook and user pool, I only see 2. Once I log in with Facebook, I get back to my application. And as you can see, all I'm doing in my application is I'm actually, if you remember the headers Priyank showed, I'm actually going and breaking those headers down into the user claims and displaying them. As you can see, this is my Facebook ID. The issuer is Cognito. My email address, bunch of other fields. So that's it for the demo. I'm going to hand it back to Priyank, and thanks a lot, guys.
Thank you, Varun. So with this, we'll end our presentation part and open it for Q&A.